All right, welcome back, guys. I'm going to give people a couple of minutes to trickle in. I'm just getting ready for the next one, okay? All right, I think we're recording. So, guys, this time around, we're going to use the same triangle, but we don't have to rotate it too much. Again, on the left, you see unit circles. You see a unit circle. Let's see. You can wedge it like this, okay? You can do that. Once you do that, I know you can't see the circle so well. Well, I can do a little better job. I can make it a little darker. Give me a second. Okay. If you wedge it like this, guys, remember this angle is 30, so this has to be 60. That makes sense. And this is half, and this is going to be square root of 3 over 2. So using that idea, I am going to label the coordinates of this point, and I'm going to say it better be based on this circle, based on this triangle. This better be, half should be the x-coordinate, and square root of 3 should be the y-coordinate. It's kind of flipped for 60 degrees. Once again, this is 60 degrees. Why is it 60 or pi over 3? Because this is 30 and this is 30. How do you know this is 30? Well, this whole thing is 180 was split into 6 parts. That's why. 180 divided by 6 is 30. So now if this point, the coordinates of this point are these, then we're going to use the same technique to go here. X will be negative, Y will remain positive. Here, both X and Y will be negative. And here, X will remain positive, Y will remain negative. All right, guys? So we kind of discussed this unit circle, this unit circle that every trig major loves. So we explained why all these points, this is for the 30 degree, this is for the 60 degree, this is for the 45 degree. And you should know 60 is pi over 3, 45 is pi over 4, 30 is pi over 6. And those signs are matching the way we did it. All right. So we have this unit circle. And that's good. But we're not going to get to it. Well, we'll actually get to it a little bit today, guys. But before we get to it, we're going to do something a little something simpler than this. Another thing I want to mention, even though that unit circle that I just showed you is the one people use, I like to separate it. So this one has the one with 45. You're going to see me use this. And this one has the coordinates with 30 and 60. So I'll use 2 because it looks too cluttered. The original unit circle that you will see in your book seems a bit too cluttered for me. I'm going to use this. All right. Now, last class, we did also mention if this is P or anything, this angle will be the same in radian, same value if this is a unit circle. Okay, so those ideas will come in handy, very handy. So I'm going to get rid of this for now. Let's do some of the problems from your book. I'm going to do a few extra problems, okay? Because this is a difficult chapter. So let's see what's going on here. Again, guys, if you can't do something, from your homework packet. You just come and ask, and I will do it for you. Okay, so they're saying don't use calculators. Fine, we won't. So they want you to find the exact value of this external function. Okay, so they're saying let's do an easy one first. Okay, let's do 21. Okay, read the text again. I'll use the same language. I'm going to give you the exam. Exam will be based on the same text. So make sure when you do your homework problem, you read the top so that you understand what needs to be done. So I'm not going to take the text, but it's here. Find the exact value. Do not use calculators. Okay. So I'm going to take this guy, and all I need is a unit circle, just any unit circle, good old unit circle. Um, this sine of this angle, 11 pi over 2. All right. So I'm just going to grab a unit circle. Let's take a simple one. Pi over 2 is a good number, but it really doesn't matter. I'll just take this one. How's that? So pi over 2. All right. So first I have to find out it's positive pi over 2. Positive means you're going counterclockwise. This is pi over 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're going to land here. So the rope that we talked about can be long enough to wrap up the unit circle multiple times. Now, I'm going to do it once again to make sure I didn't make a mistake. Let's try it once again. I'm not worried about sine yet. I'm going to get to it, but let's count it. So this is 11 pi over 2. That means pi over 2, but 11 times. What's pi over 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it wasn't too bad. So this is the point I am interested in. This is the point I'm interested in. Somehow you want to highlight it. All right. Now they want you to know, they want you to find the sine value of this point. Remember, guys, the coordinates of this point are, the coordinates of this point are x is 0 and y is -1. So also remember, guys, sine is the y coordinate. So this guy, the answer to this question is -1. That's your answer. Done. So using the same technique, let's say they gave you cosine of 11 pi over 2. Okay. This was the question. Cosine 11 pi over 2. Anybody wants to tell me what this answer might be based on what we have on the board? Anybody, guys?
0.
Thank you. Well, thank you for participating. Good. So just to let you know, guys, when you solve some of these problems, try to make some connections. Now, if you were asked to find tangent of 11 pi over 2, you would be dividing sine by cosine. There's a little problem. Cosine is 0 and we don't divide by 0. So you would say something like undefined. We're going to get to it, so don't worry too much. Any questions on this problem? And thank you again for participating. It's always nice to hear. Otherwise, I feel like I'm talking to myself. So those of you are here, pay attention. Those of some of you will watch online. I hopefully things will understand and your friends will appreciate you participating. All right. Any questions on this one? How did you do this? Why did you do that? All those things. All right. Let's move on. I'm going to do a few extra problems here, okay? Because this is hard. All right. I'm going to do 23. And and we're doing problems from 2.2. All right, so first I have to find 6 pi, which is not that bad. Pi is this, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So it's going to land here, okay? It's going to land here. Kind of makes sense. 2 pi is one full circle. and this is 6 pi, so this is 2 full circles, 3 full circles. Again, this rope, I know I'm showing it like this, but if I just wrapped it around like this, you would know how many times I went. Okay, so that's why I'm doing it that way, so that you can see how many times I circled. Okay, I'm gonna get rid of this. Gonna get rid of this. This is the point I want, and the coordinates of this point are the y coordinate is clearly 0, and the x coordinate is positive 1. Now I can do a bunch of things, right? Now, if they want you to find tan 6 pi, you have to find sine and cosine 6 pi because they are needed. You're going to say tan 6 pi is equal to sine 6 pi over cosine 6 pi. Now, hopefully the bottom is not 0. If it is, we'll just say it's undefined. Now, sine is simply the y coordinate. So the denominator is going to be 1 and the numerator is going to be 0. And that's not too bad. So I'm going to say 0 over 1. And that's 0. All right, guys. Does that make any sense? And those of you are thinking, I'm just going to enter it on my calculator, nobody will see, you're going to get caught off guard so bad later in chapter 3. Just for the record, don't say I didn't mention it. You have access, you can use your calculator all you want. But if you don't understand the basics, I can warn you, you're going to struggle so much in chapter 3. So try to understand this. They'll ask you questions that are far deeper than this. Just be aware of that.
So on the test, we're not
Mhm.
gonna have to, actually show the work like the sine over cosine. It's gonna be like the homework. We can just put the simplified.
Exactly.
Okay.
Exactly. So good question. I am showing you the work because I want you to understand it on the exam environment will be exactly same or similar to the homework environment. So however you guys do it, it'll be like that. Everybody will have a different question. Other than that, yes, you don't have to show any work. All right, guys, let's do a couple more. If we can get into, okay, let's try something with negative. Secant. Okay. Let's try 29 and then we'll be done with maybe we'll be let me see. Yeah, I think I can do one more easily. Let's try secant this guy. Okay. Secant negative pi. Okay, focus on your negative pi. Negative pi means clockwise and right here, which is not too bad. And you are interested in this point. Let's drag it here. And the coordinates of this point are -1 and 0. Okay, fine. Now, secant for cosecant and secant, you need to find sine or cosine. Now, remember, guys, secant is the reciprocal of cosine. Let's find cosine first. Now, just to let you know, you have to kind of know some of these things. Some of your calculator buttons won't even be around. You can't find it directly, so be aware of it. So I'm going to first find cosine, -pi. And that is based on my picture, based on what we have been learning so far, it better be -1. Let me go back and make sure I didn't make a mistake. -pi, cosine is the x coordinate, -1. That sounds about right. The reciprocal of -1 is basically -1. Because if this is -1, there's a little 1 here, and you flip it, you get the same thing, -1. So I'm going to claim, I'm going to claim secant -pi is -1. That's my answer. Yeah, you're going to enter -1 on your exam. What do you think, guys? Do you have any preference? I can do one more if you want me to. If somebody wants to tell me do 24, 25, I'll do it. Other than that, I feel like I'm okay with this section, not section, but this chunk. And what do I mean by chunk? These are from your text. Okay. I didn't officially assign them, but you can do them. The ones I assigned on Blades, on the MATLAB are really the same problems. Okay. This is more static. It's not going to change. And if I go to the Pearson okay, site, every time I go there, I get a different one. Similar, but different. Okay. So I'm okay with this unless somebody wants me to do one, they'll have to tell me. All right, so I'm going to try this. Let's say find the exact values of six trig functions given the angles and what else. If they're not defined, say not defined. Fine. I'm going to spend a little bit of time here, guys. Okay, so be a little patient. Okay. Remember, guys, I told you that you want to go back and forth between the angles, 210 and all that. Now, I like degrees better personally, um, but you want to know how to go back and forth. So let's do this one, okay? This one. Now, some of you will just use the unit circle, which is fine. Let me see. Let me see. Let me do it from scratch, okay? Once we are comfortable, we'll just use the unit circle. All right, guys? We're not comfortable yet, so at least I don't think we have done enough to be comfortable. All right, so guys, let's remember the unit circle we used for pi over 3 was this one. Let's bring this guy out. Let's bring this guy out. I like to do things in detail because my goal is to help you understand, and hopefully that's your goal as well. If you can see some shortcuts and you want to apply those during your exam, please be my guest. Um, so this one, pi over 3, is going to be, this is pi over 3. This is pi over 3. Pi over 3. This is 2 times pi over 3, okay? 1, 2. So this is the one I want, okay? Based on your notes, based on the unit circle that we just discussed today, those coordinates, I'm going to write it down. Let me see if I can do it correctly. Those coordinates are going to be, the x coordinate is going to be negative half, and the y coordinate is going to be square root of 3 over 2. That sounds about right. And this is the point that we are interested in. So now, why am I doing it like this? If I just grab the unit circle, which I have here, and show you, you won't have a clue. You won't get it because it's still a little new to most of you guys, unless you had a lot of trig in high school. Is there anyone who had a lot of trig in high school wants to tell us? I mean, you had a trig course. Anyone? Okay. So now they want you to find all the 6 trig ratios. It didn't say sine, it didn't say cosine. So first I'm going to find sine and cosine. Okay. Um, I'm going to write sine 2 pi over 3. That's the one I'm going to find first. Sine is simply the y coordinate. Sine is simply the y coordinate. And cosine is simply the x coordinate. The point that we are interested in. Okay, if I know sine and cosine, I can find tan, or let's do secant and cosecant. Secant is the reciprocal of cosine. I'm going to do secant first. Secant is this guy flipped, which is going to be -2. And cosecant is this guy flipped. All right, and now I need to find cotangent and tangent. I'm going to find tangent first. Remember, guys, tangent is going to be this sine divided by cosine, and you can simply cancel the denominators. So your tangent of this angle will be square root of 3 over 1, which is square root of 3, but don't forget the negative sign. So let's write it down very carefully. So we're making this claim. Tangent of this is sine over cosine, which is negative square root of 3. All right. If I know tangent, I can find cotangent because they are reciprocals of each other, okay? Cotangent is cosine over sine, and tangent is sine over cosine. So reciprocal of this is just simply, let me do it here. Sorry, guys. Right here. I have all 6 for uh, this point. I'm going to give you a couple of minutes to ask questions, just a couple of minutes. Okay, let's grab one more. Let's grab one with the denominator of 4 or 5. Hopefully there is one. This one, 52. 52. Okay, 11 pi over 4. I need to find sine, cosine, and everything. And I would like to keep this unit circle handy because this is the one that works with pi over 4. 11 copies of pi over 4, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It comes here. Okay, so having discussed it, and I'm sure we are being recorded, I'm just not going to worry about it. I'm going to put my little pink circle here. That's the one I really want. Of course, you can use your unit circle, and you are going to do, you are going to find the coordinates of this point, and based on our notes and discussion, it's going to be this. 1 divided by square root of 2, and that's going to be, the x-coordinate is going to be negative, and the y-coordinate is going to be positive. Done. Now, what is sine? What's cosine? Those are the ones I'm going to find first. Sine is going to be sine 11 pi over 4 is clearly the y-coordinate, which is 1 over square root of 2. Sorry, I need to pull this guy out. Cosine of the same angle, whether you can call it angle or the length, doesn't matter, they're the same. Cosine is going to be the x-coordinate, which is negative. If you know sine and cosine, you can easily find the reciprocals. The reciprocal of sine is cosecant, and that's going to be the reciprocal of this is going to be this, and the reciprocal of cosine is sec or secant, and that's going to be negative square root of 2 based on what we have over here. Now, tangent is fun here. Tangent is sine over cosine, this guy over this guy. They are the same. So there will be a minus sign. So tangent will be minus 1. Tangent will be minus 1. Why minus 1? Because tangent is sine over cosine. They're the same. One is minus, so it'll be minus. And reciprocal of tangent is cotangent, and that's going to be negative 1 as well. All right, so that takes care of 52. Now, it's we have been talking for almost about 55 minutes. I'm going to go over one more problem, and then we're going to stop here, and we will not do the very last section. We're going to save it for next class. It's a little difficult. You really need to talk about something very basic, and that'll be a part of our lecture. So let's do one that I kind of skipped. I skipped all the ones with degrees. So let's do one. Let's do something like 55. Okay. So now, where does 405 go? I have to know what kind of unit circle am I looking for? What kind of angles do I want? All those things. Well, 405 is more than 360. This whole thing is 360, right, guys? If this is 360, 405 is 360 plus 45. So this must stop here. Must stop here because 360 plus 45 is 405. So this is the angle we are talking about. And I happen to have the same, the right circle. This is the point they're interested in. And that's good news because that's an easy point. The coordinates are 1 over square root of 2, comma, 1 over square root of 2. And and I just have to find sine and cosine, which is not too difficult. I will say sine 405 degree is equal to 1 over square root of 2. And so is cosine because sine is the y-coordinate, cosine is the x-coordinate, so cosine is going to be the same. Now, to find the reciprocal of sine is cosecant, and that's going to be the reciprocal of this guy, which is going to be just square root of 2 if you flip it over. And secant is going to be the reciprocal of cosine, so it'll be also square root of 2. And tangent is going to be 1 because sine and cosine are exactly the same. So the tangent is going to be 1, sine divided by cosine. And reciprocal of tangent is cotangent, and that has to be 1 as well. So that takes care of, I think, our lecture, unless we want to discuss something specific. Once again, I will skip the last section. You need a good, fresh mind to start this. We are going to go over it next class. It's actually a little challenging, but we'll make it through. Trust me. And other than that, guys, I don't have anything else to add. If you want me to do something, you have to ask, and I will be happy to do it. So as we have been doing, I'm gonna jump out of this session. I will upload the videos, but I'll be available. If you have any questions, please feel free to ask. Other than that, we are done for the day with regard to recording, but I'll still be around if you have any questions. Thank you, guys.